Welcome to surveying class. So today we'll be discussing lecture number 14, that is the profile leveling, and unit 4, that is measurement of vertical distance. So if you recall, in the last few lectures we are discussing about the vertical distance measurement using the level instrument. So primarily we are discussing about the dumbbell level, auto level, and the total station. These are three instruments which is used for the vertical distance measurement. And in the lecture number 13 we have discussed about using the dumbbell level, how exactly the surveying or vertical distance surveying is done on a field. So we have seen that there are basically three types of different leveling instruments, and with this, what are the different steps, how we make this elevation, how we take the measurements in field, that we have seen in details. So today we'll be discussing a very specific topic of leveling, that is the profile leveling. So if you recall, what we have discussed in the last class is this is the ground terrain, and what we have is that we have the benchmark, we call it, right, where the uh, all the elevation points is known to us, that we call it benchmark BM. So with respect to this point, we find out what is the elevation of this point, like the multiple points, we find it out, elevations at different points using the dumpy level. So what we keep the stuff at this point, and then maybe we place the instrument here and find what is the height here. Similarly, we take backside, port side, we have discussed in details in the next class, in the last class basically, and we find out what is the new elevation for the final point, right? So today we'll be discussing about profile leveling. What is profile leveling? For example, you want to construct a road or a railway track, okay, if in a city or maybe on a region. So what you have to do is we have to, the railway lines, it going through in a linear path, is not it? Or maybe a highway road, so highway is also going in a linear path, means it crosses across the region, right? Something, this is the path, or maybe this is the railway track, something like that, right? So in that case we have to track the profile of the terrain, right? So in a linear fashion, how the ground is varying, the depth is varying, elevation is varying, that we have to find out, that we call it profile leveling. So let's get started about the profile leveling. So the profile leveling is a method of surveying that has been carried out along the central line of the track. So for example, you want to construct, maybe this is a region somewhere, something like that, and the road is passing through it. So this is a railway bridge, or maybe a highway is passing. So this is a highway. So along the central line of this path, basically we have to take the surveying here. So this may be the central line of this track. Right, so along the center track, basically we do the surveying. So this is maybe our benchmark, we know. The remaining intermediate points, we find it out what is the elevation at each dot. So in the, basically this is the center line of the road, and that actually we call it, it is a profile leveling. So we are basically leveling the profile of the entire road. So the operation involves in determining the elevation of ground surface at small spatial interval along the line is called profile leveling. So basically every 10-meter interval, 10, 15, 20, depending on the project, we take the points, and each intermediate points we find it out what is the elevation. Okay, like that entire thing goes. So the route along which a profile is run may be a single straight line, as in case of short workway, or a broken line, or in case of transmission lines where like we keep the swell line also, right? And for the water supply also we lay down the pipes. So that for that purpose sometimes we need to do the profiling, because always water flows from high end to low end, right? So if you find it out the profile of the entire city, like in which side the up is there and which side of the city down valley is there, so such that it will be easy for us to lay down the water pipe networks into the entire city. So for the purpose, the profile leveling is very much important. So now you understand why profile leveling is important. And sometimes we construct the canals also, right? The river is flowing somewhere outside outskirt the city, and somewhere we have the agricultural land here. So what we do, we construct the canal, right? So canal also water will flow by gravity. So that's why we have to make this profile leveling, so that we can understand which area is higher elevation, which area is lower elevation, so that water can flow from higher to lower elevation. And also sometimes if you construct a road, so sometimes we need to cut the hill, and sometimes we need to fill the valley also. So profile leveling, it basically helps us in identifying how much earth cutting is required, and earth filling is also required. So now you understand the profile, how the important the profile leveling is for the any projects such as, as I mentioned, railways or highway tracks, highway roads, or the canals, or the laying out of water treatment plants, water treatment pipes. We need the profile leveling. So in this lecture, basically we'll be discussing how exactly we'll do the profile leveling in field in a step-by-step manner, and we'll try to solve a couple of problems also. So the station, as I mentioned, that profile leveling means basically you have the road, right? So you have the starting point, which you call it benchmark, and then multiple intermediate points we take, right? So these points, sometimes we call it is the stations. So the line along which the profile is to be run are to be marked on the ground, right? So every 10-meter or 15-meter interval, we keep one peg, basically survey pegs will be there, right? So to mark down that this is our station. So every 10 or 15-meter we do, so the stakes are usually set some regular interval which depends on the topography, accuracy required, nature of work, scale of plotting, etc. It is usually taken as 10-meter. Normally we do take it 10-meter, and every 100-meter, one big station we call it full station. So these every 10-meter stations we call it intermediate stations, whereas every 100-meter or so one station we call it full station. Okay, so at the beginning station of the profile is labeled as 0.0 plus 00. So the first point we call it, this is the first station. That name of the first station we call it 0 plus 00. So 0 indicates what is the number of full stations. So this is first station. This is not a full, this is first station, right? So this is 0 plus 00 is the first leveling. Now if you want to level the second point, it will be 0 plus 10, means this distance is 10-meter, for example. So this is again 10-meter, so this will be, so this point also will be 0 plus 20. So when you reach to 100, so maybe this is 100-meter, so this will be 1 plus 00. So next will be 1 plus 10. So like that it will go flow. So first digit, this is the how many full station you have covered, and remaining, and this one is the how much distance it is from the previous full station. So that is the nomenclature we use. For example, a point which is actually 153.25 meter from the beginning point, then we denote it, it is 1 means because 100-meter is one full station, right? So it's a 1 plus 53.25 is the nomenclature for that station or for that point. So like that, basically we identify the stations and we do the surveying. So now let's see the procedure here. So in carrying out the profile leveling, a level is placed at the convenient location. So for example, what you have to do, so this is the profile leveling we are doing. So see, the profile is not, not a flat profile. It is undulated, hill, valley, both are there, is not it? So now we'll be starting our experiment or the measurement from point A. So point A is our benchmark, means we know what is the height, elevation, everything, for the point A. So this is, for example, 105.61 meter. So this is the from mean sea level, what is the height that is given to us, or we know that, right? So now from there we first place instrument at the L1 location. So L1 is something like maybe a convenient location where the good flat, little flat ground is available. There we keep our instrument here, L1. Okay, so this L1 will keep it. Now what we'll do, we'll take in every 10-meter interval we take one point. So from a 10-meter we take first station 1, so we mark it with a peg. Next 10-meter we go, and this is the second point, third point, fourth point, until and unless next station we got approximately 100-meter maybe. So this is the full station. Okay, or maybe if any obstacle is there in middle, then that may be also a full station. Or maybe a carve is happening. So for example, the road is the road you are constructing, the road has a carve. So for example, okay, let me, yeah, so some bend is there. So if any bend is there, means what, although 100-meter may be here, but as there is a bend, so in the bend also we take one full station. Right. Similarly, if there is very steep down is there, so in that case, there also you can consider multiple full stations. So because visibility should be there, then only we can take the measurements, right? So based on the visibility also, some additional full station also we may edit on our track or on our route. So anyways, so initially first we kept our instrument at L1 location, and every 10 meter we marked it with 1, 2, 3, 4 with the peg, right? Now we start taking the readings. So first from L1 we cited this A, this reading we call it backside, right? So because this is the benchmark, we know this is backside reading we have taken 3 point something 005 meter. Then we shift the stuff at location 1, and again we take what is the measurement. So now we know the height. So using the rise and fall method, what we discussed in the last lecture, and also the height of instrument method, any method you can use and find what is the elevation at 1. Similarly, you again sight it at, you keep the instrument, give the stuff at 2 and sight it what is the elevation that you get it 2, 3, 4, 5. So and then the B station. So B station will be again we have to shift the instrument, right? So what we have to do, we have to take the fourth site at B, and again you shift the instrument to L2 location, and again you take the back side of B. Okay, so now you can establish what is the point elevation at B. So once you know the B, again the process will continue same. You keep the instrument, you keep the stuff at 5, find out what is the distance, so what is the height. Similarly 6, 7, 8, this will go on. So until the entire road will do surveying such in that way. So this point basically we call it, changing point. Is the B is the changing point, because in this B basically we have shifted our instrument, is not it? So the distance is also measured in the line. So horizontal distance also we are measuring every 10 meter 15 meter interval, one peg we are keeping, and we are finding out the profile. So this is the actual plan view. If you would see every 10 meter distance, so this is the first, L1 means we keep the instrument L1 here, right? So this L1, it may not be in the same line, is not it? So L1 may not be in the adjoining line of A to C. It is not maybe in the same line. You can keep it in a little opposite distance also. For example, this one is L1. See, L1 is not in the same line. It is maybe at some distance you keep it, because we have, the land also should be uniform where we keep our instrument. So also this distance also we have to measure it. So from L1 to A horizontal distance. So L1 to 1 station, this distance. So like that, this distance also you can record. And as I mentioned, this B, C, these are actually turning point. We call it TP, turning point 1, turning point 2. So and like that it goes. So this is the procedure for the profile leveling. So now while measuring the measurement on a site, we have to maintain the field book also, as we discussed in the earlier classes, last classes also. So this is the table somehow we have to maintain in the so the first is the station A, where the benchmark means we know the latitude longitude, that is our first point A. So in A basically we take the BS, right, backside. So A is denoted as, so this is basically 0 plus 0.00. This is actually here, not here. Just take this correction here. So this point is basically 0 plus 0 0. Next the first station it will be 0 plus 1 0. So second station 0 plus 2 0, like that it continues. Okay, so the first station always we take the back side, is not it? And then all the station 1, station 2, station 3, these are all intermediate site. So here one additional column is added, that is is. If you see, if you recall, last class we have only two column, one is backside BS and the fourth side FS. Now we have the intermediate site also, IS. So 1 2 3 4 is all these are all are basically intermediate site, right? So next full station is at B. So the fourth site will be taken at next full station B, and middle stations we call it is the intermediate site. So the concept is same, but the name has changed because the full station is now 100 meter apart, and middle we have taken many intermediate points. So that's why this site is called intermediate site. And similarly, using this height of the instrument method or the rise and fall method, any one method you can deploy it, you can find out what is the RL of each reduction level. You can find out what is the each point, what is the elevation. So like that table basically we have to make it on a field, and we have to maintain the record. So this up to the staff reading we'll do it on a field, and from this different level, from this portion basically we come to office and we fill the table, and then we plot the profile. So this is the profile plotting you can see. So now you understand how the profile exactly looks like. So different measurement you have taken, and all the height and rise and fall, all these values you will plot it on a graph or a plane, and then you see exactly how the profile looks like. So this profile is very much useful for understanding before construct. For example, a road you want to construct, so that means here it is very high, isn't it? So here you have here cutting of soil is required, whereas here in this portion this is a valley portion, so here filling of land is required. So where whatever you cut the soil here, you fill it here. So like that, profiling is very much important. That's why actually we do this profile leveling. So the plotting of profile leveling provides a graphical representation of the ground points on the longitudinal section along the alignment. So along the alignment, basically we get the now profiles, longitudinal profiles. So it is being used to determine the depth of cutting. As I mentioned, the depth of cutting and depth of filling is very much important. So how much soil has to be cut. So the figure shows the longitudinal section of profile leveling. In this, basically this is the datum line. Right? Datum line means where we have the known elevation. That line we call it datum line. Okay. So because this is the datum line, means this first point is already known. So 10 point something like 10.4 benchmark point. So there's through that point, if you draw a line, that will line we call it datum line or the reference line. So like that, basically we can construct the profile of a region, and this profiling will be useful in many purposes. So whatever we have seen in the last slide, that is the profile. Profile means this type of profile you make it. Now if you want to construct a road, then sometimes we need the cross-sectional profiling also. So what is cross-sectional profiling? For example, let me draw a terrain. So this is the area, for example, a road is passing. So this is a road is passing, is not it? So road has a width also. Right, so whatever profile we have done it, that is a longitudinal profile we have do it. But sometimes we need to do the cross-sectional profiling also. So this is the cross-section, right? Cross-sectional profiling also we have to do it. So what cross-sectional profiling? So basically 3 to 5 meter from both sides of the center line, we do this cross-sectional profiling. So this is a cross-sectional profile you can see. So this is the center line from where we are doing longitudinal profiling, and from the center line, 3 meter or 6 meter left and 6 meter right, we find it out multiple points, and this type of profiling we call it cross-sectional profiling. So now we understand one is the longitudinal profiling, what we have done in the last slide, and this one is the cross-section, means what is the, if you take the cross-section along the path, so this is how the diagram looks like. So in many projects, basically terrain information traverse to the longitudinal section is also required, right? For example, road construction, the highways or canals, on that longitudinal cross-sectional view also required. So in those cases, surveying is carried out on the right angle of the center line. So this is the center line, this middle line, the center line. So right angle of center line is this vertical, this horizontal line, is not it? So those lines, basically we have to do the surveying, and for if any reason cross section is running in any other direction, not in the perpendicular to the center line, but some inclined line, if you take it, then that record also you have to maintain it on a diary, and accordingly the calculation has to be changed. So the reduction level are plotted here. You can see at the different point, the reduction level are plotted, and you can see the cross-sectional view. The road also here, it is not flat, right? Cross-sectionally also road is not flat, you understand. So here also profiling is required. With this top portion, maybe you need to cut it. So this top portion, maybe you have to cut it and you have to fill it somewhere here, so that the line should be flat, or maybe somewhere like that you can take it. Okay, let me draw it. Yeah, so this may be the road. So this top portion you can cut it and you can fill it here. So that is the advantage of using the cross-sectional profiling. So now let's solve a quick example of this profile leveling. So what is given in the question? Following are the staff reading taken with a level. Level means you can consider dumpy level, or auto level, or the total station with any instrument level. So the instrument having the having shifted after 4th and 7th and 10th reading. So RL of the benchmark is given as 100 meter. Enter the reading in a form of level book page. Find the RL station apply use LJ. So this is the staff reading is given to us. So what it said is the benchmark. So first station is the benchmark station, which is 100 meter RL is given to us, 100 meter, right? So the first reading will be always the back side. So this is back side, right? So let me draw it here. So this is the profile. So this is our first point, that is 1, and here it is given benchmark 100 meter. elevation is 100 meter from the mean sea level, this point, starting point. So now we keep our instrument somewhere here, and first, we take the backside reading. So first reading is the backside. So 2.665 is the backside reading. You can see that's why we have written it here. So next is we have taken few intermediate points. So intermediate point means first is this is the first station, second, third, fourth, fifth, and next you have the uh, next station, next full station, maybe station 2 or station B, something like that. So each for so first station we have taken the back side, and next all are intermediate side, all are intermediate side. So this is, that's why you see this is the intermediate side, intermediate. And what it is mentioned is that after fourth and seventh and 10th reading, basically we are shifting the instrument, right? So after fourth reading, so 1 2 3 4, so after this reading basically we are shifting the instrument. So backside, 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 and this is again the fourth side, isn't it? Fourth side. So that's why it is written as a fourth side for the next station, because after this we are changing the shift, we are shifting the instrument in new position, maybe in this position. So again you shift the instrument at new position, and you have to take the back side, is not it? Backside FB. So this one is the backside. So 2.645 is the backside, and again this is intermediate side. And then from the again from the seventh reading, again we have shift the instrument. So first, second, third, fourth, fifth, sixth, seventh. So after this reading, again you have shifted the instrument. That means this is again the fourth side. So that's why it comes again in its fourth side. Now when you shift it in the new position, then this reading will be the back side. So this is back side again, and then next reading will be the intermediate side, right? And then after the 10th reading, again 1 2 3 4 5 6 7 8 9 10. So after this reading, again you have shifted the instrument to third location, right? So this will be again the fourth side. So this is again fourth side, and this is the back side. So 2.60 will be the back side, and this is the intermediate side. So this is the how we fill the table. Okay, so we have to understand how exactly measurement is taken on a field based on the conditions given in the question. So now once you fill the back side, intermediate side, and fourth side, these three columns, now using either use height of the instrument method, or you use the rise and fall method, and you find it out what is the RL of that respective point. So the first point is basically backside, you got it 2.655, right? And the RL is given to us is 100 meter at point 1. So the first point RL is given. So what is the height of instrument at this point? It is 100 plus 2.655. So 102.6. This is height of the instrument. And remark you can write is benchmark. So next you kept now you kept the stuff here, and you measured the height is basically 3.745, is not it? So the height of instrument already so from there you simply subtract this value, you get what is the RL at second observation station. Now similarly third observation station, you got this one. So from height of instrument you subtract this value, you get this is the RL value. So 102 minus this value, you get this one. So now first step is over. Now again you shifted the instrument into some other location, is not it? So now height of instrument also will be changing. So now what will be the new height of instrument? That you have to find it out. So how will you find it out? A new height of instrument. First you check, what is the level difference. So the level difference is this minus this, you get a level difference. So that you have to add it in the previous height of instrument. So that is added here. So and based on that you can compute what is the new RL point also. So once you get it, the same process will repeat, and every time you find it out the new points, RL points, then ultimately, you fill the entire table. So at the end, you can check it total back side and minus total fourth side, both should be equal to 0. And if you get it, that means a small error you got. No, that is the value, and the first point and last point RL difference also you should get the same value. If it is matching, then there is no error. There is no error in the reading. Otherwise you have to rectify the error. So that we have discussed in the last class. So again let me I explain what the surveying goes here. So this is the ground terrain, right? So initially this is our first station, number 1. Okay, this is the benchmark we know. So this is the elevation at this point is 100 meter, that is given to us. Now the next station is after 10 meter, maybe this is our station 2, station 3, station 4, station 5, station 6, like that, all station I have noted down. So the first reading, maybe we kept the after fourth reading, right? We shifted the instrument. So initially maybe our instrument is at this location. So first we have taken the back side at 1. So this is our first reading, 2.655. Next, you have taken the intermediate side at 1, at 2, then at 3, and then we have, no, and the fourth reading is this one, that is basically the fourth side of 4 1. So this one is the fourth reading. Then you shifted instrument from this position to maybe this position you came. So now first you take the back side, is not it? And then you take intermediate side. So like that, we have to fill the tables. This is very much important. You have to first understand how exactly the surveying goes on in the field, and how we progress from one point to another point, and then we fill the table. So this concludes this lecture, that is the profile leveling. Now you understand the profile leveling, what is the importance of profile leveling, why we do the profile leveling in field, and also we have seen, using the example, how the calculation is done, means how exactly you can plot it, the profiles, and also the sectional profile also we have discussed in details. So this concludes this lecture. Thank you.